Hey guys, today I'll be working on Python programming, so the continuation of that series. We'll be working on comparing strings and moving on to if, elif, else, and booleans. Like the actual variables. The last time you kind of saw them hidden if you're watching the series. They were like booleans that were there, but you couldn't really see them. So now we'll go over that later on in this video. So here we'll just start off, so I'm in Pycharm again. So I'll be using Pycharm, so here we'll just say password points to input. So here we'll say enter a password or your password. And on the bottom we can have, below that we'll have excuse me, so we have if password is equal to, so you're going to have to put quotes here. If password is equal to my password, which it won't be because we'll enter something else. And then we'll enter my password too. Here we'll have print password accepted. So we could use that for, like, for example, so like once we could shift it onto the next screen, like in Android. I'll try to actually do an Android video today. But guys, if you guys are interested, but here if we do password accepted here, it could go on to the next screen. Or the next screen. But if it doesn't, then let's just say pretend like it stays on the same screen. So here we'll have else. I think I need a shift semicolon up here. So here we'll have else print password incorrect. Excuse me. Sorry, my throat's getting all stuffed up. So we have that should be all here. So we'll just, do we need to set a breakpoint? We don't really need to. We can though. Something wrong with that? No, okay. So here we'll step over that, enter your password. I'll have to enter something in the console, so I'll enter like trees or something. So if password is equal to my password, so if I go back to the debugger, here we have our password here is equal to trees. I clicked on it, you can see it in the blue highlighted bar right there. It says our password is a string type and it's trees. They just use single quotes, I guess, to show it. Excuse me. Spelled it wrong too. My apologies. So if we have, actually, yeah, that wouldn't have worked either way. So I'll just fix that. So we have password both now. Both are the same. I'll re-click the debugger. You don't need to click on that line as long as you have the breakpoint. I think it works. So the cursor could have been here. Breakpoint would have started here either way. So here I'll step over or in. It doesn't really matter, I think, at that point. So here we'll have, again, I'll enter trees. Here we have if password is equal to my password. Well, it's not because our password is trees, so this whole block should get skipped, including that I. That all should get skipped to here. So I'll step in. It's going to skip to the else because password wasn't equal to my password, then we'll have print password incorrect. I'll step over that, and then here, and print it here, enter your password. We didn't put a new line here. Next time we can. That would have separated those two lines so it looks better, they're on different lines. But here, if we put trees here, so I'll just click run this time. So enter your password, trees, password. This time password accepted got printed out. But if I re-click that here, sorry, if I rerun it here and I put tree, password incorrect because it didn't have that S on the end. So hopefully that makes sense. To compare strings in Python, they use the ASCII table. So if you don't know what an ASCII table is, you can Google ASCII table. It should take you to ASCIItable.com or look for that, or .org, ASCIItable.org. They're an organization. So pretty much the ASCII table compares, so every letter on the keyboard, every symbol, every number has a special number associated with it. So for example, and it goes by lowercase and uppercase. And I don't know if they have all symbols, they have some symbols. They don't support all languages. For example, the Unicode character index, which is what they use in Java and other languages. They use Unicode, which supports more languages, like other than English, like other foreign languages and all that. So for example, the capital M would have like a value of 77, for example, in the decimal section. So there's different sections on that. There's like an octal. If you don't know, octal is a different kind of number. Hexadecimal is like a different kind of number. It's a type of number. And they'll have like decimal. So if you look on the decimal, which is DEC on the ASCII table, if you pull it up on your screen or somewhere, I'm not sure if it's exactly the same, but a capital M might be like 77. A capital A might be like that, has a value associated with it, which is like 97. A lowercase r will be like 114. A lowercase y will be 121, and so on. The space itself has a character, I believe, like a number associated. And even like the number 4 would have its own value that might be like 43 or something. So that's how the Python interpreter compares these strings. Each, if you look on the screen again, each letter has a value associated, as we said. So this would be like, for example, I don't know what T is, but it'll be like 70. This T will be 70. R will be like a certain. So there are a certain number of ways the alphabet. So like A would be like 1 and 3 would be C, for example. 1, 2, 3, right? A, B, C. So A is 1, 3 is C, something like that. So T would have a special value. So if T is like 70, then R would be like however many spaces between T and R. So like let's just say 57 or something. Maybe 47. 57, something like that. A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T. Okay, not that far, so maybe like 62, 63, something like that. Then E would have a value of like 13, then this value would have a value of 13. And it's going to compare the password you entered to trees. If you only have 4 characters, trees is always going to be the bigger one, so you can compare them with greater than or less than as well. Greater than, less than, and greater than equal to, less than equal to, and all that. Okay, so we'll just move on to the next code here. So we'll have, we'll do some less than and greater than things here. So we'll have name1 points to input, which is going to ask for the string enter a name, last name, enter a name, last name first. And here we'll have name 2, which points to input. Enter another name, sorry. Last name first here. Then name, sorry, not name. Then here we'll have print. Sorry, not printf. Here are the names listed, don't need a comma there, listed alphabetically. Spell that right? 2 L's? Okay, yeah, so here are the names listed alphabetically. Then we'll have, here we'll have a conditional if name 1, so if name 1 is less than name 2, and we'll have print name 1, print name 1, print name 2, else print name 2 and then print name 1 backwards, so it's the other way around. Okay, so we'll isn't too confusing, so we don't really need to step through this code. Once we get into some complex stuff, we'll step through, which we don't really need to right now. Like for data structures, you definitely need to step through them if you're learning to help you understand what's, because it's pretty hard. Like it's not impossible, but it's more of a definitely challenge than this. I have a whole data structure series on Java if you're interested. I still have tons of videos to upload. They can get complicated, but it's once you get it, it's like it's not the most difficult thing of programming, but it's up there. I think recursion is probably the number 1. Number 2, data structures. So if you got that, you pretty much got, you know how to do the hardest thing. So here we'll have so if name 1 is less than name 2. So first we're gonna have to enter a name here. So let's just say, what's an alphabetical name? So if we just have so like here we have Bob, and the next one we have Cam. Then it should print Bob Cam. But if we flip them around, okay, maybe let's debug this just to show what's happening exactly. So I'll step over, actually no, sorry, I have to enter something here, so I'll say enter a name. We'll just enter one name here, so just Bob. I should say that's their last name, and then the second name. Enter another name, last name first. Let's just say it's just Cam. What happened there? Oh, sorry, I didn't step over that. Apologize. Okay, here I'll enter a name here, Bob. Then I'll have to step over. Then I'll have to enter Cam here. So here are the names listed alphabetically. If name 1 is less than name 2, so if we click on the console here, sorry, if we click on the debugger, so we have Bob and Cam. So name 1 is Bob, name 2 is Cam. B comes before C on the ASCII table. So it's going to compare letter 1 to letter 1. Index. So index starts at they start at 0. So Bob would be, I believe B would index 0, O is index 1, and the second B is index 2. For Cam, C is index 0, A is index 1 and M is index 2. So it's going to compare index 0 to 0, and once they run out, if one has more than the other, that one will be automatically greater than the other one because there's more characters. So here, if name 1 is less than name 2, well, in this case, Bob is less than name, because it compares each letter to each, it compares each index with the starting index. So if you have B here to compare it to C, so B will always be less. But if you go O compared, if it basically goes by the first letter first, and if it's the same, then it goes to the next index. So hopefully that makes sense. So if there's like 2 Bobs, I'll show. We'll change the names in a sec. So we'll step in. So it's going to print name 1 and then print name 2. So it printed Bob and Cam. Let's do something similar here, like BAB and BBB, just to show you guys. I don't think I really need to step over those. We don't need to debug it now, so we'll just do enter. We'll just let's just say their last name. So we'll say Bab and Bob, and Bab's going to be first, because if name 1 is less than name 2, in this case it is, because the first letters were the same. But this time, thus it compared the second letter, it went by the second letter in this one. But if we flip them, so if we go Bob and then Bab, if name, do you go Bob and Bab? So if name 1 is less than name 2, if name 1 is less than name 2, so do we enter Bab? Bob. Do we do Bab first? No, I think we went Bob first. Bob and then Bab. So it prints out the names alphabetically. If name 1 is less than name 2, print out name 1 first, then name 2. But in this case, we entered Bab second, right? So therefore it flipped it. So it didn't print Bob, because we had name 1 was not, so we entered Bob for name 1. So is Bob less than Bab? It's not. So therefore it wouldn't have printed Bob first, then Bab. So it said, okay, well then if name 1 is not less than name 2, so there's only one other option in this case. So basically if it's not less than, then it's greater than. So there's only 2 options. So it's gonna, if you don't know that already from other languages, then it's gonna flip it. So it's gonna say, okay, well if name 1 is not less than name 2, then name 1 is greater than name 2. Therefore this one is false. So it's gonna print out. It's gonna flip this condition here. So it's gonna, then we had it print out Bab first. We got it to print out name 2 first, which was Bab. That's why I printed Bab, and then we printed name 1, which is Bob. So Bab and then Bob got printed. So hopefully that makes sense. We'll move on to the next example. Alright, so now we'll do if, elif, and else. So that's how you compare strings. Is that everything? It should be everything there. Can I make it any more clear though? We know if you have, for example, Bab with 2 B's or Babby, baby, right? Then it's going to be more than, it's going to be greater than Bob, because there's going to be more letters. So it's going to take it as a bigger string. So the one with less letters is going to be always the smaller one. Okay, sorry. So we'll just do sorry. So now we'll go on to the next code with the if, elif, and else. Okay, so let's go with sorry, is this we just did Bob? We just did this string comparison code. Got that out of the way. Okay, so now we're on to the next one. So if, elif, else, I don't know if this one actually has an elif in it, but we will be going over that in a second as well. Could we do a few more of the string comparisons? I don't think we really need to. I think we pretty much got them down. I mean, if we have more, then they're more. A space would be more as well, included as a character. Same letters we compared. Yeah, that should be all. That should be all the concepts of comparing strings. So we'll just go on to the next one. That is this code here. So we'll just start with it here. I don't know if it actually has an elif in it. Maybe just two else's, but we'll just do it anyways. So here we'll have, we'll say min salary points to 30,000 as a float. Then here we'll have min underscore years points to 2. And here we'll have a salary. Salary points to float casted to input, the input function, and then we'll say enter your salary. Sorry, enter your annual salary. Did I spelled it right? Yeah, I did. Okay, so enter your annual salary. So it'll take input from the keyboard or from the user, from the device, whatever. And we'll say years on job points to int casted to the input function. The string for prompt is enter the number of. So here we can break these between spaces for some practice. So we'll have a concat here, as we learned in the last video. Years, enter the number of, and then years employed. So here we'll have if salary is greater than or equal to min salary. So if salary is greater than or equal to min salary, have to go, yeah, that has to go on the outside here. So we'll have, so if salary is greater than or equal to min salary, then we'll have if, so this is, okay, so this is a nested if, that's the example here. I'll explain in a sec. So we'll have if years on job is greater than or equal to min years. Gonna need another semicolon here. Print. So here we'll have print. You qualify for the loan. Oh, this book stupidly doesn't have any indentations on it. I think I know what they're doing though. So they have. So I'll explain in a sec. So this this else is gonna go with this if. So it matches the nearest if that makes sense. And they should be in line with the one that they match. In this language, I believe they have to be in line exactly. In other languages, they don't have to be in line. You could have them. You could have one here, like one all the way here, but like for example, the C or Java interpreter will know that they match because they're the closest. They're the closest matching if to the else or else to the if. But I believe in Python they have to be exactly aligned. See how there's a line there showing that it's exactly under the exact same amount of spaces away from. I think it's a tab. No. Well, in this case, it's one more over. So 1, 2, 3, 4. Actually, it is a tab. So it's one. So this if away from that wall on the side is 1, 2, 3, 4 spaces. This else is 1, 2, 3, 4 spaces. So it has to be directly the same in line or the same amount of spaces indentation away to match it, I believe. So here we have else. We have you qualify for the loan, and then else print. We'll have a print here, and then we'll say you must have been employed sorry, we could keep this on the same line here, so we'll have you must have been employed for at least. Then we'll pass in here comma and then min years. So you must have been employed for at least min years, comma. So it's only going to print the number, so we'll have years to qualify. So then here we'll put some in here as well. So that else statement, we're missing one, aren't we? Yeah, so we have one here, and we'll say I don't like that like that. That looks better like this. No. Python wants it like this, I guess. We'll have else. So we want here print you must earn at least $. Format min salary. I need another quote here. Dot 2f. Comma dot 2f. This is getting a little confusing here, so we'll have you must earn at least that's fine. That should be all here, so let's have a look at this here. So what happens is we have our min salary at the top, min years is at the top, so these are constants. Salary points to float, so enter your annual salary. Years on job, enter your years on job. If salary is greater than or equal to min salary, if that's true, it'll jump into the next if. If that's false, it goes to the matching else clause, which is this one. You can check that because it's indented in line. And it's the most closest matching else. Not this one because that one's nested with the tab. That matches this one. So let's just say this is true. If salary is greater than or equal to min salary, that condition is true, then the code execution will jump here to that if here. Then it's going to say, okay, well, we want to test if years on job is greater than or equal to min years. If that's true, you qualify for the loan. It'll print that. If that's false, it'll say you must have employed for at least this many years on the job. And if back to the first statement, if this is false, then it'll say you must have earned at least this minimum salary. So let's set a breakpoint here, just starting to get a little bit confusing, so we'll set a breakpoint. I'll click the debug icon in the top right corner. Here we'll have, I'll click on the debugger, I'll step over, so min salary points to 30,000 here. That's a float variable, it's a constant, and well, it's a constant because we said it's a constant with capitals. I don't think there's an actual constant keyword in Python. The language creators decided not to have one. That's alright. Perhaps since it's capital, it might not. The Python interpreter might not let us change it, but maybe not though, because maybe not. Actually, I don't think it would though, because sometimes you do have capitals with other variables. You can test it out if you want to. Anyway, so here we'll have min years is points to 2 in this case. Why is that double? I'll just re-debug that here. Min years not defined. I think it's a glitch. Anyways, we'll step over here so we delete that. Okay, let's stop that. Something happened here, something glitched out. So we'll say, we'll just restart it here, so we'll have min underscore salary points to 30,000. Min years points to 2. Salary points to float. Input, so here was asking for input, cast it to a float. So enter your annual salary, let's just say it's like just say it's $100,000. We'll hit enter. We'll say, okay, well the years on job is enter the number of years employed. Let's just say our min years here is 3. So we'll meet the requirement. So if salary is greater than or equal to min salary. So if we go back to the debugger and check our variables here, we have so if salary, which is 100,000, is 100,000. So if we have, so if if 100,000, so if salary is greater than or equal to min salary, which is 30,000. So we're saying if 100,000 is greater than or equal to 30,000, so that's true, right? Because so you can ask yourself, is 100,000 greater than 30,000, which it is. In that case, we'll execution will jump here because it's true. And it'll say, okay, well now it's going to ask us if years on job is greater than or equal to min years. So years on job is 3, min years in this case is 2. That'll be true again. Print, you qualify for the loan because everything was true. These need new lines. I thought they print out, aren't they supposed to automatically print new lines? Oh, it's input, maybe that's why. Yeah, these inputs should have maybe new lines here. So we can add some in. So now we'll show what happens if the salary is met and the years on job is not. So we'll just remember to do that here. So salary is met, so we'll say our salary is 100,000 again. Enter the number of years employed. We're not going to debug because we just went through, so I showed you guys how to do that, so you guys get the idea at this point. So we'll just go enter the number of years employed. This time we'll just do 1. This time you must have been employed for at least 2 years to qualify. See, this time everything was the same except for here. So if salary was greater than or equal to min salary, maybe I'll just show you through the debugger. It can be confusing when you're learning conditional, so I'll just restart it again. So we'll have step over, step over, step over. Okay, so enter your annual salary, 100,000. Is that enough zeros? Is that only 10,000? Yep. 1, 2, 3, 4, 5, 6. Okay. Enter years on job. Enter the amount. Enter the number of years employed. In this case, we'll only do 1. So if I go back to the debugger, then we have if salary is greater than or equal to minimum salary. Min salary. Oh, it is because 100,000 is greater than 30,000, so this will be true. We'll jump to that statement when I hit step into. Then it says if years on job is greater than or equal to min years. We have years on job is 1, min years is 2. So is 1 greater than or equal to 2? It's not, right? Because 1 is not greater than or equal to 2 in math. In a math equation. So in this case, this line gets skipped. You qualify for the loan will not get printed. It'll skip to else because this statement was false. Because if a statement is false, if an if statement is false, it automatically, if there is an else clause, it jumps to the closest else clause, I guess in Python within the indentation. If there was no else clause, it would just go on to the next line. That was outside the block. In this case, the block is the indented block. So hopefully that makes sense. So here we'll step in, jump to this else. Print you must have been employed for at least, I guess it'll print min years and then years to qualify. So min years is 2. So now we have everything spaced out because we added those new lines. So here it says you must have been employed for at least 2 years to qualify. And that's all. That's the end of the code. This time we'll just do a minimum salary is less than the required amount. So minimum, sorry, just skip over that, skip that, okay, enter your salary here. So your salary only made $100 this year, unfortunately. The market was rough. We got fired. Okay, so here we'll have, so min salary was, so years on job points to int. So years on job points to int, so it's going to ask for a casted int to the input function, which again will just enter the number of years employed. Okay, yeah. Enter the number of years employed. Let's just say the number of years employed was 0. So if salary is greater than or equal to min salary, well, is 100. We have in our variables here, so salary again is 100, min salary is 30,000, so is 100 greater than or equal to min salary? It's not. Therefore, this whole block will get skipped. So everything in the indentation block to the closest else clause. A clause is like a statement, so to the closest else clause. Almost said elf, like Christmas. Okay, so the closest else clause to that if, not coding wise if, but just like if there is an else. If there's no else clause, if there's no else clause here, if there's just one if and there's no else clause down here, but there's a code, then that code will always get printed because it's part of the normal execution in code, in Python in this case. So I can show that in a sec. So we're here, step in. So here we jump to that else because this statement is false. You guys understand that hopefully at this point. Then we have, it'll print this line here. You must earn at least, whoops, I messed that up. So it should have printed the min salary, but I did that in quotes. There shouldn't have been any quotes with that. There we go. Is that correct? Nope. You must earn at least, I think I'm missing a bracket here maybe? No. There we go. That's what it should be. Okay, so you guys get the idea. I should have printed that number there, but we had that wrong. So this line should have got printed if you guys understand anyways. Since this line here that I highlighted on line 6, if that was false, if this if was false, it's going to jump to the closest else clause in its indented block. This one won't get counted because that's a nested to that if. So remember the closest if in the block. So it's not part of that block. This is an inner block because it's indented. So closest if closest to its else or else closest to its if in its indented block, which is this is its indented block here. So therefore this line should have got printed, which it did. Right. But in this case we just had the we had this formatted wrong, so you must earn at least. It should have printed the minimum salary, but it printed the string minimum salary. We printed the capital min underscore salary in all uppercase because we had a quote here. Like that, so it printed that actual line, it printed that actual string. We wanted to pass that variable min salary in here, so that's what it should have happened, so hopefully you guys understand that anyways. And now we'll do we do everything here? I think we did do everything here. Oh yeah, what we said is we're going to take this else away. to show that this line will get printed either way. So we'll step over that, enter your annual salary. I should say we made some money in the market, but we didn't make the minimum required amount. Actually, say we made like 29,999. It's not going to catch it because it's off by 1. It shouldn't. So then we'll have, let's just say we made enough for rent and groceries, but we didn't cut it for the loan. So we'll have, so 29,999.0. We'll enter that. So years on job, we'll enter something here. So we'll say enter the number of years employed. So we'll say 0. Say that was just from our personal business, and we'll say, okay, so if salary is greater than or equal to min salary. So if salary is greater than or equal to min salary, so if 29,999 is greater than min salary, which it's not, then as you can see, this whole block got skipped. And after that else clause, there was nothing else part of this if block, which is kind of confusing without brackets. But here, this line gets printed every time whether anything's true or false, because it's out of the if block and it's out of the else block. So there's no conditionals. It's just back to normal execution to code at this point. So hopefully that makes sense. We're just gonna end it here. It's getting to be 40, almost an hour here, so 47 minutes. So hopefully that you guys understand nested if and else. So in the next code, when we come back, we'll go over some probably go over some if, else, and elif. Maybe another nested statement before that. We'll do some more logical. Okay, so we have to do logical. So we went over relationals, which is greater than or equal to, greater than, less than equal to. So then Python also has logical operators. So logical operators, that's basically and or. So in Python they use the actual excuse me, falling asleep. So in Python you actually use the actual A and D, like the actual sentence, and kind of like if and else. But in other languages they use like the actual symbols, like 2 ampersands and 2 shift forward slashes, one of those up and down lines. But in Python they just use and or, so we'll be doing that, and then we'll do booleans. Oh, sorry, they also have not. So and or and not. So there's 3 of them. Not is just the exclamation mark. Actually, I think in Python it's just it's the word not. So Python's more like English. So we'll be going over that. So hopefully you guys are learning. It's relatively straightforward, pretty easy at this time. So hopefully you guys understand. Hopefully you guys didn't get confused on these nested statements. So yeah, so we're just gonna end it there. Thanks for watching. If you guys like the channel, you can give me a thumbs up and subscribe to the channel for more programming videos and investing stuff. And I'll see you guys next time. Thanks.